Hello, my name is Lewis Talley with InSource Solutions, and today I'm going to be talking about I/O data simulation. Before we dive in and look at the actual software, let's spend a little bit of time introducing some of the concepts about what it is, how do you get it, how do you use it. So the OI simulator, as it's called, is part of the Wonderware communications driver pack. So you may be familiar with those in the past. They were referred to as DA servers. The next generation of those is OI servers. Now they're called the communications pack drivers. So how you can get it. So you can get it a number of different ways. It's been included as part of the installation routine on the system platform disk since one of the 2017 releases. It's definitely part of 2020 and the 2020 R2, which is what I'm using. You can also get it as a standalone. So you can go to the Aveva tech support portion of the website and you can download it under device drivers, I think it is, and it's called the Comms Pack. So you can just search for Comms Pack. Or you can literally just install it as part of the system platform install. So that's what I did. It's now called communications drivers, and there's a number of different ones that install as part of the core. The cool thing about the installer is if you're using this current version, you really don't have to think a whole lot about it, other than once you install it, it's pre-configured, which I'll go over some of that configuration here momentarily. Really all you have to do is make sure that it's running. One of the things that I personally found cool about it is that when I first started using it, I read through the documentation, and I was like, this seems a little confusing. And really it's sort of designed to just put in and just kind of use if you want to. So really what it's designed to do is just be a great tool to test things. So you don't really have to spend a lot of time thinking about it. I've used it for lots of client projects to just simulate different types of data. Now it's sort of once you install it, you sort of set it and forget it. So let's talk about how to use it before we sort of dive in and look at it. So overall, there's different algorithms that control how it generates data. And so those algorithms sort of dictate the type of pattern of data, if you will, that gets generated. And so like I said, it's sort of a set it and forget it type thing. So you can sort of ignore some of this part and zoom forward, or if you're interested, I'll sort of give a brief explanation of all the different algorithms that are built into it. You can also see this from within the README file. So the algorithms apply to the overall, you'll see in the configuration, the overall device node level, or they can be on an individual point. So what I'm talking about is you could have one point that generates a sine, another point generates cosine. So the algorithms that they have are cosine, none, random, sawtooth, sine, string, toggle, and triangular. So, you know, the point that I just made, you could have one that generated cosine data next to one that generated sine data. And so you can specify that on a per point level or overall at the server level. And so you can also control things from within the algorithm, like the range of values and how quickly it's changing and things like that. So I would sort of say those are more, not advanced necessarily, but more advanced things from a configuration perspective that probably not everybody's going to want to change. And also it's helpful to note sort of just a little bit of a how-to for any time you're communicating to a Wonderware driver. The device groups are topics. So when you install the OI simulator, it pre-builds a configuration element, which you'll see in a second, that has some device groups built into it. So those are topics. So if you want to make any Wonderware piece of software communicate with any other Wonderware piece of software, you need to know the application name, the topic or device group, and then the item name. And then, of course, if it's on a different computer, you need to know where that driver is located. And then I'll go through it and talk about what some of the clients are that I use. So in my demo that I'm going to show, I'm going to use two clients. I'm going to use first the application server, just because I think what we're doing now with some of the pre-built galaxies just makes that even quicker to be able to get useful information out of this OI simulator. So with that, stand by and I'll switch into the software and actually show you. Okay, so now we should be looking at the SMC, the System Platform Management Console. So you can get to that from a number of different ways. I have mine pinned here. It's just the SMC. So it's typically where you would go and you would see, things like your Wonderware log, et cetera, et cetera. Now this is a brand new image and I intentionally haven't done anything to it just to show you how easy it is to use this. Actually, I told a little bit of a fib. I actually did go in here and start this thing. So when it installs, it configures everything and it doesn't actually start it. So to start it, you would interact with it by right-clicking on it. In this case, I selected the activate option. Yours would probably be red to show that it's not running. So this is the basic configuration of it at the entire level here. So you can see, by default, it's configured here with this random. And I'm not going to spend a ton of time talking about that. I talked about them in the beginning. You can go through and see in the help file if you're curious as to how to tweak that if you want to. One of the neat things about it that I like is that it sort of pre-configures these device groups for you. And that's neat because, if you've used other OI servers or DA servers, you have to know what that device group is, or sometimes there's a default. And it's just, I can very quickly be pulling data out of this thing. There's no device items in there, but that's sort of an alias that allows you to sort of go through and say, here's what I want to call it, here's what its actual address is. So the way that this thing works, and this is what I found a little confusing from the help file, basically, you don't have to give it any sort of item naming. It sees the data type and it tries to generate some data. So if you tell it string data, it'll generate string data. If you tell it analog data, it'll generate analog data. Or Boolean data, it'll do Boolean data. So it sort of looks at the data type and allows you to very quickly be generating data from your system. And so what I've done on the back end is I've pre-built there's probably a lot of things going on in this screenshot that you're looking at here, but I've pre-built just the default galaxy. And the reason why I did that is because with the 2020, it also has the pre-built simulator, in this case OPC client object, to connect to that OI simulator. So it's a standard Wonderware communications driver, so you can communicate with it via any of the native protocols, whether it's Wonderware, SweetLink, or DDE, or OPC. The neat thing about this Galaxy is it's all pre-built and has all that, call it the plumbing infrastructure, built into it. So if, for instance, it has in the OPC client, it already has pre-configured the scan groups that are set up in the OI simulator, in the SMC. So I didn't have to add all that. So it makes life a lot easier, and I can more quickly be seeing data out of the system. So how quickly can I do that? So all I've done to this Galaxy, I built it today. All I've done is just deployed it. There's no objects. So if you want to see how quickly you can be generating data, I'm going to do something that you probably wouldn't do in the real world, is just create some base instances here. And I'm not doing any template planning or anything like that. Just going to leave the default name. And I'll go through and let's just say that I want to add an attribute with my system. An attribute with my object here. And I'm not going to do anything other than maybe just change the data type. And I'm going to turn this on for I/O. Now, I'm using auto binding, and one of the cool things that this Galaxy does is it pre-assigns things, right? And so what we're talking about here is you got to fill in what the I/O address is if you're not using auto binding I/O, right? So this is doing it for me just because it's specified a default. But if I didn't do that, it's literally just as simple as dragging and dropping over here into my I/O devices group the object into the appropriate scan group that gets defined in this OPC client object here. So there's other videos and documentation that talk about that. I didn't have to do that here because I already have these bolded areas here and engines. These are my default areas. So the system sort of takes care of that for me. So I've been talking a whole bunch here, but the net effect is basically all I had to do was create an instance of something, create an attribute, which I could have done in the template, and deploy that. All right, so that's deployed. So remember, I just added an attribute and left the default name. So we'll add this to watch. And you'll notice that it's generating data. So I didn't have to do any scripting or custom coding. I remember back in the day of having to build randomized data demos, and you had to do a whole bunch of scripting. So, in a few mouse clicks, even with me talking probably a minute or two worth of effort, I could very quickly and easily be generating data. So that's one of the really cool things about this. Of course, now that it's already in an object, I could do things like push that over to the Wonderware historian or build a graphic for it or something like that. So let's talk about some different types of clients and ways that you can use this. So this is the way I'm using it now. Think of that as just, sort of simulated data. So now let's shift gears into a less glamorous client, the Wonderware Client. This isn't a commercial for the Wonderware Client. The Wonderware Client, for those that are not familiar, is just a basic text tool for testing connectivity and things like that. So it doesn't have a lot of the fluff that some of the other technology has here. So I basically need to know the name of the application that's going to be servicing the I/O requests and the name of the topic, right? Which, that's either normal, fast, or slow, or your own if you want to build your own in there. And so I'm not going to spend a ton of time talking about this, but just using the Wonderware Client. This is the thing I really like about the OI simulator. So you could call something whatever you want, and you can just say, I want to advise on that value, right? So I'm going to zoom in just so you can probably more easily see this. The data is not updating when I'm zoomed in, but you can see that, but I never told the simulator to what A was or anything like that. So you can just, generate stuff all day long just by throwing these values in here, right? I can just call them different letters or numbers or whatever. So the system uses a rules file to basically look at what you've, told it here. And so in this case, if I haven't, prefaced it with anything, like if I want a floating point value, I can say something like, FD, right? And just say advise. And now notice, again, when I'm zoomed, it's not updating. Now notice that I've got a floating point piece of data. So if you want to see what all those rules are, the syntax for the file, the syntax for how all that works is listed in the device data types, right? So that's just if you're generating data using one of the algorithms, right? So in this case, it's random. So if we go back to the random points here, you're just randomly generating data between, in this case, whatever the range group is. So I think it's 20 by default. So it's, just randomly generating data between 0 and 20. Another really useful way that you can use this is that you can have it act like it has a process value and a set point in it. So the way that you do that is just like with other things. So instead of having, just A, I might have, let's actually pick a different one. Let's pick G. So I might have G, and if I put a period and the letters .pv on it, that tells the system that I'm going to have a process value. So now if I add that point to it, I can also add something called the set point. And so the way that the simulator works is based on how you configure, if you do configure whatever the algorithm is coupled with any additional parameters that you add here that I'll talk about in just a second, it'll bounce around whatever the set point is at basically whatever the deviation or the noise is around the signal, right? And the cool thing about it is I can come in here and I can change the value. So let's change that set point to, 200 or something like that. And now if I should have said write that value. Now watch the 200. So the value, I'm going to zoom back out here in a second. This value is going to track more towards this 200 value, and it'll bounce around whatever that set point is. So you can go through here and you can set the set point or the process value or the deviation or that noise. You can set that on a per point level, or you can set that at the overall server level. So that's one of the things I really like about it. So basically if you go in and you build a bunch of things and you call it PV and you have something else, you call it .sp for set point, you get a really simple way for building simulation applications that can track data. And, if you're using a technology like application server, like I just showed you here, if I wanted to go in and add the same sort of concept here, right? You do it the exact same way. I could just have, we can call this thing Lewis.pv. We'll call it an integer. And then we'll go through and duplicate that, and we'll call this Lewis.sp, make that an integer. Let's turn on input. Save it. And redeploy. Same sort of thing. If I can find the object viewer, there we go. So let's wait for that to refresh. Now let's see if we can find the PV and the SP. So it's allowing me to dynamically define these on the fly here. So if I change this to 90, you'll see my set point here. I changed to 90. My process value is going to start zooming up here to 90 here. Remember, it's not live data as I'm zoomed in. And then bouncing around whatever the deviation and noise is. So, I personally have had to do that without this tool and building a simulation structure through scripting and random number generation in .NET or something like that. This is much, much easier. So anyway, just wanted to spend a little bit of time sort of quickly showing everyone, how useful this thing can be. It's part of the 2020 install, or you can download it separately. If you have any questions, feel free to put them in the chat, and we'll respond back to them. Thanks, and we appreciate your time sitting in today, and have a nice day. Thanks.